All right, Java 3, welcome. As I understand it, there was no class today. Should have known better, but some guys attended, so I'm making this video for those of you that could not attend. The next assignment is a fun, kind of challenging one, designing a class called fraction, which represents a single fraction object, right? So I actually have my completed version here. Don't look at that. We are going to go file new class, and I'm going to call this one fraction 2 so it doesn't mess up with my current fraction. You can call yours fraction. That's fine. And finish. Now we have a nice empty class. Okay, first thing we're going to do, put that java.comment comment at the top, right? You got the slash and the 2 asterisks. Boom, you hit enter, and look what Eclipse does for us. It creates some space to work in, and it defaults to giving us the name of the author, which is me, and it will be you when you do it. You can also add some other javadoc tags. I like to do add version, and we'll just say it's version 1.0. You should also replicate the name of the class, so we'll do fraction 2.java. Actually, I should probably go first. Put that up here. And let's put the date in there as well. Those are the things you should always add to your top comment, in my class anyway. Okay, so now we have our class, fraction 2. When you're designing a class, there's 2 big categories that you need to focus on. The first is obviously your data members, and this is the easy part for a fraction, right? What data is required for a fraction class? And the class answers, you need a place to store a numerator and a place to store a denominator, right? You don't need anything else. In the real world, a fraction is well represented by those 2 numbers, and so in the programming world, you would probably try to match that. Don't try to overcomplicate it, right? So you've got a numerator and a denominator, and clearly those should be integers. So we'll type int, and I like to put a my in my data member names to indicate that they belong to each object in which we will be with which we'll be working. So we'll int my numer, int my denom, and if you're paying attention, you realize that what I have left out is the access modifier, right, which dictates the places where we can directly access these variables. And because encapsulation is important, because we want to protect that data at all costs, we should always make our data private. That's it for the data, right? So now we move on to the methods. And the first methods that we want to write will be the constructors. And one constructor is pretty straightforward, right? If you want to create a fraction that has a numerator and a denominator, you probably want to have a constructor that accepts a numerator and a denominator. So we'll write that one first because it's the most intuitive. We want our method to be able to be called from other classes, otherwise there'd be really no point. So we're going to say public, and the return type, which would normally be the next thing that comes in our method declaration, is there is no return type, right? Unique thing about constructors, you don't return anything. There's not even a void, right? So we just skip that part. And the other thing that's unique about constructors is that they share the same name as the class, which in this case is fraction 2. And what are my parameters? Okay, I'm going to have 2 integers. One we'll call num in for the numerator in, and the other one we'll call denom in for the denominator that's being passed in, right? And the basic version of this constructor is easy. We're going to say that my numer is assigned the value of num in, and my denom is going to be assigned the value of denom in. Okay, yay, we've written a first constructor. Oh, what have I done? Oh, I misspelled denom up here. Okay, good, yay, successfully have written a constructor, right? And what I asked the guys in class today, we'll call it class, was would it make sense to have any other type of constructors? And the answer is yeah, probably at least one, right? Because in this world where we have fraction objects on which we are going to be doing fraction math, we have to accept the fact that there are also going to be whole numbers, right? Like the whole number 4, how do you represent it in a fraction world? It would just be 4 over 1. So it might be helpful to have a constructor that only accepts one number, that number being the numerator, and the denominator obviously being assigned a value of 1. So here we go with our second constructor, right? We're overloading the constructor. And this one we're just going to say int num in, and we will say iNumer, assign the value of num in, and my denom, assign the value of 1. Okay, we now have two different constructors we could call on, and I'm going to ask you for this assignment to also write a third constructor, a default constructor, right? Default means that we aren't giving it any arguments, and so I want you to write a third constructor. If you passed in no other information, then presumably one wants to create a fraction that is a 1 over 1. Would that be useful? Not sure at this point, but I want you to write it anyway. Go ahead and write a third zero argument constructor, which creates a fraction of 1 over 1. Okay, so you'll have 3 constructors. I'm only showing you 2 of those. And next we want to move on to accessor or getter methods. Oh, and yes, I forgot. I want to be demonstrating good process along the way. So let's go back to the constructors, and I want to be putting my java.comments comments in. And again, Eclipse is great for this, right? You put the slash and the 2 asterisks, boom, you hit enter, and it creates this java.comment comment, and it gives us the tags for our different parameters. So I'm just going to add a comment saying creates a fraction with given numerator and denominator, and at param num in, we say the value assigned to the numerator, and denom in the value assigned to the denominator. Okay. So you should do that for all of your methods. I'll skip this one down here. Right, I think we know what accessor methods are, right? You want to create methods that allow you to get at your numerator and denominator, which otherwise are, going to be protected because they have that private status. You won't even be able to look at them in a different class. So let's go ahead and put one of those in. It needs to be public so we can use it, and the naming convention is pretty standard. We'll just do get numer. We don't need to give any information to that method for it to do its job, so we don't pass in any arguments here. It's just empty, and it's a very simple method, and we just do return my numer. I think that's what I called it. Okay. Oh, and I forgot the return type of that is an int, since my numer is an int. Okay. So you should do that, obviously, for my denom as well. And again, let's do the java.comment. Okay, getNumer returns the given numerator, and at return, the numerator. Yes, I know it seems redundant, but just do it. That's what the pros do. That's what professional developer code would look like. So go ahead and do that. All right, so you should have all of the accessors. And the main point of this is to be able to do math with these fraction objects. So eventually I'm going to ask you to write code for all of the mathematical operations, division, multiplication, addition, and subtraction. And I listed them in that order because once you dive into this, you'll realize that it's much easier to write multiplication and division than it is to do addition and subtraction. So your assignment thus far is just to take care of multiplication and division. And let me show you how I want to do that, because there's a few different approaches you could take. Here's the way you should do it. Okay, these methods will be public. Let me put a little comment header, and we'll say mathematical operations. Give ourselves a little space to work, and we'll do public fraction, because the result of the mathematical operation is going to be another fraction, right? Even if we do 1/2 plus 1/2, what gets returned is going to be 1 over 1. Everything is done in fractions in this world in which we exist. Let's do multiplication. Or let's keep it simple. Let's do multiply. That's a little easier. And we're going to pass in another fraction, so we'll do fraction other. Okay, and how do we want to do this? All right, well, we're going to need to generate a new fraction. So that new fraction is going to have a numerator and a denominator. So let's do this. Let's do int new numer. And the new numerator is going to be the result of multiplying the numerator of this object, that is the object that's making the call to this method, and the numerator of the fraction object that's been passed in, which we're calling other. So the new numerator is going to be equal to, well, let's see, how do we get the numerator from this object? We could do a couple of things. We could just say my numer, right? We could call on getNumer, but I think it's most clear if we refer to this, right? This means from this object, from the one that's making the call. So we're going to do this dot getNumer times other, so the object that's passed in, dot getNumer. Okay, and we're going to have to do the same thing to get the denominator. I haven't written the getDenom method yet, so it's not going to like this, but we'll do it anyway. Int new denom is assigned the value of this dot getDenom, right there. It's unhappy, sorry, times other dot getDenom, method we have to write. Okay, so we have the new numerator, we have the new denominator. That doesn't mean we have a fraction yet. We got to create that fraction. So we'll do fraction result or product, something that makes sense, is assign the value of new fraction, new numer, new denom, and the last step, of course, is